kind of relate back to some things we talked about in Chapter 1. If you look at this equation in vertex form, there should be something a little familiar about the way this thing is written. Remember in Chapter 1 in Section 1.6, we were talking about transformations, stretches and shrinks and slides and all that kind of stuff, translations. Do you guys see a translation in this equation? Horizontal and vertical? Okay. What's the horizontal translation in there? Yeah. Left 2. And what's the vertical translation in that equation right there? Down 1. Do you see that in the graph? See how we've just taken x squared, we've moved it left 2 and down 1? Okay. Vertex form, really, all it is showing you the translation. Okay? So, it does give you the coordinates of the vertex, but ultimately, it's what we've already talked about with any function. It's showing you how far it's moved left or right and up and down to place that new vertex, which originally was at 0, 0, in a new location. Okay? So I think it's helpful to think of it that way too, so that you can see where that thing's going to land. Let's see. Oh, all right. That being said, there is a shortcut to get to the vertex if you have something in standard form. Okay? So I would be remiss if I didn't show you that, because it is helpful for a lot of people to do it this way instead. And this is a formula that, again, should look familiar. So the shortcut to the vertex, if you have something in standard form, f of x equals ax squared plus bx plus c. The x-coordinate of the vertex, negative b over 2a. Does that look familiar to you? You've used it before. Maybe you don't remember, but you have. And then if you want the y-coordinate, it is f of that. You plug that number into the function, and that'll give you the y-coordinate. Okay? So let's take our last example, and we'll quickly get the vertex. The answer should come out to negative 2, negative 1, right? So if we've got this f of x equals 3x squared plus 12x plus 11. Whoops. So let's say my only goal is to find the vertex. I sit there and do all that completing the square. I don't need to graph the thing. I just want the coordinates of the vertex real quick, and that's it. So the x-coordinate of that vertex, negative b, negative 12, divided by 2a, 2 times 3. Okay, so what is negative 12 divided by 2 times 3? Negative 2. Okay, and then if I want the y-coordinate of the vertex, I do f of negative 2. So 3 times negative 2 squared plus 12 times negative 2 plus 11. So just plug it in. And this is going to be 3 times 4, that's 12, minus 24, plus 11. So that would be negative 12 plus 11, negative 1. And look at that. X is negative 2, y is negative 1. So our vertex is the point negative 2, negative 1, just like we found before. Okay? So, like I said, if the only goal of the problem is to find the vertex, then there you go. Okay? Now, that being said, you can use this trick to help you even if the problem asks you to write the equation in vertex form. You don't have to complete the square necessarily, because once you know the vertex, think about it. This thing into this form. My pencil stops breaking. If the goal was to put it into vertex form, so that would be a times x minus h squared plus k, right? If you remember what this form looks like, that it's set up like that, you already have the h and the k now, right? The h is -2 and the k is -1. So without having to complete the square, okay, assuming I didn't do any of that work, just doing the little shortcut here, I could do, okay, I got x minus -2, so plus 2 squared, and my k is -1. I've got that much. What's the only thing I have left that I need to find? A. Well, if I started with the equation in standard form, guess what? You have A. Here's my original equation, right, once it focuses. Right here. What's A? 3. Oh, sweet. Okay. Done. So there's really no need to complete the square. However, I felt like it's important to show that to you because it does get used for other things later, but there's a way around it if you want. Okay. So, talking about that, we need to move into finding zeros, which is a lot of what we're going to do down the road. Okay, and a lot of what you did in Algebra 2. Okay, so this should be very familiar. Okay, and you guys had, remember this in Algebra 2, there was a whole chapter on finding zeros of quadratics, and each section was a different method that you used to get the zeros. Does anybody remember a method that we used in Algebra 2 to find the zeros of a quadratic? Quadratic formula. Quadratic formula is the pro of the quadratic formula always works. You can always rely on the quadratic formula to get you what you want. Drawback of the quadratic formula, it's messy. Yeah, it takes some time, and it's easy to make mistakes in the middle if you're doing it by hand, that sort of thing. But pretty good, pretty decent go-to. Any other methods you guys remember that you'd used? Factoring. Yep. The pro of factoring, if the equation factors, it's generally pretty quick. The con to factoring, sometimes it's difficult to factor. Or maybe sometimes it doesn't factor at all, in which case that method doesn't work at all. Okay, but that's a good one. What we're generally going to do is check to see if it factors. If it does, do that. If it doesn't, go to the quadratic formula. Okay, so these are going to be our big two that we'll focus on. Now there are some other methods that you guys did, okay, which we are not going to generally look at, but still work. One was completing the square. Okay, it works, but the thing is it's messy and easy to make mistakes, that sort of thing. Quadratic formula, I think, is a little bit more straightforward and reliable. Graphing is the other thing, which we will touch on some when we start talking about some of the calculator stuff we're going to do with this. I mean, if you can graph a quadratic on your calculator and then look for the x-intercepts, okay, yep, that works. Okay, but assuming that we don't have a calculator to work with, we're really just going to rely on the top two. Okay, so like I said, our method is going to be number one, check factoring. So if it works, obviously use it. If not, then we're going to go to the quadratic formula. And we should probably, for those of us that don't remember it, write down this quadratic formula that we speak of here, because we're going to be using it quite a bit. So negative b plus or minus the square root of b squared minus 4ac all divided by 2a. If you don't have that memorized yet, you should. Okay, and I think by the time we get to our first quiz, we'll have used this thing so much that you probably will just have it memorized anyway. But if you don't, I mean, that's just something you need to know. That's a pretty standard equation that we're going to continue to use this year and in AP Calculus quite a bit. That just got to know it. So, all right, so let's see if we can use this guy to